series of Snap Circuits videos, we're looking at projects 246 to 257, and we're starting off with the two-finger touch lamp. That's what it is in the book, and there it is on board. And here we're using our 1100 ohm resistors connected in series through our red LED and NPN transistor using 6 volts. And essentially the reason they call it two-finger touch lamps is we're going to touch one end to our gate on our NPN transistor, then we're going to touch the other end up here so we get 6 volts traveling through us to turn on our LED. So if I take my finger there and put the other finger here, you can see our LED lights up, and lights up fairly bright. Now if I went to only 3 volts, you see it doesn't light up as much because we don't have as much voltage there to turn on our LED with through the transistor unless I go up here and get the full 6 volts. And again, depending on how much pressure I put on there, I can kind of adjust how bright the LED is. See, that's pretty good right there. If I let off some, it starts kind of going out and kind of starts to flicker once I take it all the way. So that is how project 246 works. Now project 247, we're going to modify this circuit a little bit. Here on project 247, the one-finger touch lamp. There's what it looks like in the book, and here it is on the board. And essentially we modified project 246 by rearranging the circuit around so that we have another resistor on here, our R4, or which resistor is that? The 10,000 ohm resistor. And essentially, instead of using 2 fingers like we were with 246 and 247, we're just going to use 1 finger to turn on our lamp here. And by having the connections close together like that, I just take something like my thumb and press it on the connection, and our LED lights up. Basically what we're doing is we're using our 1 finger here to bridge that connection together so that the NPN can get enough current through its gate to allow current then to pass through our LED and turn our LED on. So that's how project 247 works. Now project 248. So next one we're going to look at our space battle. So here we are with project 248, the space battle. There it is in our book and on our board here. So we got 6 volts, and we're using our Space 4 IC, obviously from the title, so we're using our Space 4 IC sounds. We got our red LED to give us some visual input along with visual output from our 6-volt lamp and audio from our whistle chip. And we control the Space 4 IC with both our slide switch and our push switch. So we turn the slide switch on. Our LED comes on for input, and then we see our output on the light and hear it from our whistle chip. And we can also use our press switch, and you notice that both our LED and our lamp get brighter because we're providing 2 input sources for our Space 4 IC here, so that it allows more current to go through it. And of course we can change the sounds around by manipulating the slide switch and press switch. So that's how project 248 works. Now project 249 is Space Battle 2, and on that we're going to remove our slide switch and replace it with our photoresistor and control the Space 4 IC using light. So when I put it on there, it immediately turns on. Then I can cover it up, change the sounds. Of course, our press switch still works. I can use the photoresistor with it now. So that's how project 249 works. Now project 250 is going to be our multi-speed light fan. So here we are with Project 250, the multi-speed light fan. There it is in the book, and here it is on the board. Now we're using 3 volts this time with our Space 4 IC. But we reconfigured it so now that our LED is on the output along with our motor. And I've actually turned off the air conditioning in the background because if you remember from way back, the motor also acts as a speaker in a sense because it uses magnetic coils just like a speaker does. So we'll actually be able to hear the Space 4 IC as the motor is running. So in this case we've got our press switch, and we're again using our photoresistor to control it. So let me put the photoresistor on. So you see our LED lights up nice and bright. And our motor's not turning with the sound it's putting out right now, but it is outputting sound. You can hear it through the camera there. Of course, if we have our photoresistor turns off, I'll take my finger away. See, we can see the different sound that the Space 4 IC is playing from our LED, and you can tell that our motor is spinning up and slowing down and spinning up and slowing down depending on that output. And because it's multi-speed, we can increase the amount of current to it with our press switch by making it play a simultaneous sound. So your LED changes there, and our motor's running at a higher rate of speed now. Change our sounds there. To get a different sound there. Yeah, we got kind of the pulsing one, which we can see from the LED, and the motor itself is pulsing as well. Got a different sound there, and the motor speeds up. So that's how Project 250 works. Now Project 251 is to light and finger light, and with that we're going to replace our motor with our 2.5 volt lamp. So while I'm covering up the photoresistor here, I'll take the 2.5 volt lamp, put it here, and now when I let it go, you see our LED doesn't really light up, but our light does because of the amount of current that's going through it. And we can see that our LED and light are flickering because of the sound outputs of the Space 4 IC. Change it again. So that's how Project 251 works. Now Project 252 is going to be storing electricity. So Project 252 is storing electricity. Here's the project. There it is on the board. And here we got 6 volts again using our NPN transistor with our 100 1000 ohm resistors, our green LED, 470 microfarad capacitor, and our output we're paying attention to is our 6 volt lamp. So if it's storing electricity, you probably know how this is going to work from previous projects involving capacitors. So we turn on the slide switch that makes the circuit live. So I take my 2-snap and we're going to connect it across these 2 points with our LED capacitor. So our green LED lights up bright and then gets dim and then goes out completely. And as we know, that's because current is flowing into the capacitor and the capacitor is now fully charged. Now we take our 2-snap and connects the point from our capacitor to our 100 ohm resistor feeding the gate of our NPN transistor. And you see our 6 volt lamp starts bright and gets dim very quick. It basically pulses. And we can repeat this again by charging our capacitor back up and coming back over here and make our lamp flash. Charge our capacitor and make our lamp flash. And because of that, essentially what's going on is we're charging up our capacitor, and our LED is representative of that, and then we dump the stored energy of the capacitor through the gate of our NPN transistor, allowing a large enough current to be going through the collector and emitter, which has our 6-volt lamp connected to it, and that allows the lamp to momentarily come on. And as the capacitor discharges, less and less current gets through the gate, so then less and less current ends up going through the 6-volt lamp through this portion of the transistor until all the energy is used up, in which case the light can no longer light up. So that is how Project 253 works. Now Project 253, excuse me, I was looking at the wrong one, is lamp brightness control. So here we are with project number 253, the lamp brightness control. There's our project there in the book, and there it is on the board. And we go back to 3 volts here, and I realized that my other battery pack is starting to get pretty low, so I'm going to have to recharge that. But we use our 2 transistors together, NPN and PNP, to help amplify the amplification, so to speak, of our current passing through for our lamp here, because we're using our variable resistor here to control the amount of current going through the gate of the NPN transistor, which then controls the current going through the gate of the PNP, and then that adjusts how much current goes through our 2.5 volt lamp. So actually have the circuit on already, and when we bring our resistor up, we see our lamp just start to turn on there after the halfway point, and as we continue to push up more in that resistor, it gets brighter and brighter until we get to the very top, and now we're at the peak. And then of course we can go back down to where the filament is just barely on in the lamp. Now it's off. Then we can go back the other way and turn it back on and adjust its brightness. And I think that pack is starting to get a little low too. It looks like the slant is not getting very bright. So that's how Project 253 works. Now Project 254, we're going to replace the 2.5 volt lamp with our motor. So let me take the lamp off here real quick. And yeah, it looks like I'm going to have to recharge my battery packs there pretty soon. So positive, we want to go this way. There, take it there, put our fan on, put this all the way down, and then we turn the circuit on now, and now we can adjust the speed of our motor with the same circuit setup. So we can start off nice and slow, or we can ramp it up, or bring it down some more, where the motor is just running. Get it to where I can get it to kind of just run there. And we can wrap it up. Bring it down some. And all the way to 0. So that's how Project 254 works. Now Project 255 is our radio music burglar alarm. So here we are with project number 255, the radio music burglar alarm. There's the circuit in the book, and there it is on the board. So I brought out my little battery eliminator since the AA rechargeables I've got are on the charger now, so we'll use this for the remainder. So we got our slide switch with our intended variable capacitor, because this is going to transmit over an AM radio frequency Our little red LED gives us a visual indication when the music IC is playing, and our NPN transistor acts as the trigger mechanism to both turn on the music IC but also keep it in a loop as long as there is current flowing through that NPN transistor. Now, no current's going through it right now because we have the circuit grounded out with this link over here. But when that link is broken, of course I don't have the circuit on, the music IC will play and it will repeat, and then if that is grounded there, it will not allow the device to play. So this would be connected to a wire short or something like that that can be triggered by a sensor or something. We'll turn on our radio so we can hear it there, and when this link is broken, it plays the music, and of course it broadcasts it over AM radio, which is what we're picking it up with our speaker and Sony Walkman here. And if the link is reconnected, of course we divert power away from the NPN transistor, grounding it so that the alarm no longer goes off, and of course we can set it off again. So that is how project number 255 works. Now project 256 is going to be our light dimmer. So here we are with project number 256, the light dimmer. There it is in the book, and there it is on the board, but since we're using our battery eliminator circuit, I've had to modify the circuit a little bit since we don't have another battery holder there. So when you build it using these, just build it like it is in the book and it'll work the same way. So we have 6 volts with our PNP transistor using our LEDs or output, along with 3 of our resistors, R1, R2, and R3, and our 100 microfarad capacitor, which we can charge up using our press switch. So right now there's no circuits connected, there's no current going anywhere, but when we press our press switch, see the LED kind of dims up and then goes to full brightness, and that's because when we press the press switch, the current flows through our capacitor first and charges up our capacitor, and then when the capacitor is charged up, then we start getting current through our LED instead on the PNP there. Now when we release the press switch, now we close that part of the circuit so it's no longer charging the capacitor, but now the capacitor is discharging through the gate of our PNP transistor, and because of that our LED stays on, and of course as the capacitor discharges, the LED gets dimmer and dimmer until the capacitor loses all of its charge. And we can repeat the process if we press the press switch. So our LED took a little while to get up to full brightness because it had to recharge the capacitor. And once we release it, the capacitor is now discharging back through again the gate of the PNP transistor, allowing the LED to stay on. And again, as less current flows through the gate of the transistor as the capacitor discharges, then we have less and less current going through that LED, which is why it gets dimmer and dimmer. So that is how project 256 works. Now the last project we're doing is project 257, the motion detector. So project 257 is a motion detector. And here's what it looks like in the book on the board. So we got 3 volts, and we got our red LED and slide switch controlling our NPN transistor, and then we have our photoresistor going through our variable resistor here, and that's going to control the current going into the gate of the NPN, which then determines how bright and whether the LED is on or off there. So we have our variable resistor set to about the center position. We turn our circuit on, and our LED lights up because our photoresistor is getting light into it, allowing current to pass through it and turn on our LED. So if I cover the photoresistor up, the LED goes out because it's not allowing any more current to go through here to the gate to turn the LED on. Take it away, it comes on, And because the photoresistor controls current via the amount of light that hits it, we can adjust the brightness of that LED depending how far away our hand is, because we're casting a shadow over it, limiting the amount of light that strikes that photoresistor. So we can go completely out, or we can have it on just a little bit, or we can have it on a lot, halfway, and so forth. So that's how Project 257 works, and that concludes this set of Snap Circuits videos.